Okay, so we are on YouTube live now. So hello and welcome to everyone. This is our first instruction webinar, that is second after weekly webinar. Today we're gonna be talking about some classification and regression models. So I think you all are doing supervised learning right now. So in supervised learning, basically there are two classes or two categories: classification and regression. In classification you have, okay, let's first let me share the slides first. Okay. This was the weekly webinar. Okay. Okay, so as you can see in the screen, is the screen visible to everyone?
Yep. Yes.
Yeah, okay.
Yes.
As you can see on your left side, there's a graph of classification. I actually have copied the images from the internet. I should have put the source here, but while doing the assignments and the projects, you should keep in mind that whatever image or code or anything you use, please mention the references here, because it is very strictly recommended in assignments and projects. So in classification, the problem is basically to divide a data set into classes. For example, in the left side, you can see that the black line here is our classifier or a classification model. It is dividing the entire data set into two parts. The red ones are for disease and the blue one is for healthy people. So it takes gene 1 and gene 2 as the independent variables. So basically on these basis, it tells whether the person concerned has the disease or is he healthy. In regression, we do not divide the data set into classes. We actually try to find a value. For example, in movie ratings, if you want to rate a movie from 1 to 5, you will have to consider several categories like the genre of the movie, the director of the movie, the actor of the movies, uh, and based on this basis you can predict the estimated movie rating. For example, if soon the Avengers will is gonna release, so for the Avengers second part you will see the past track records of the Avenger movie, the storyline, the people, the previous ratings, and then you can say that on an estimate it will cross the IMDb rating of 9, something like that. So here on the left side you can see that line divides the 2 points, while on the right side the line is trying to fit itself into the points. You all have done the linear regression. So this regression graph um, is for the linear regression. Actually, in real life scenario, it's very hard to find such kind of data where you can fit a linear regression model. Here it is trying to do an approximation of the data. Um, so today what I have planned is we are gonna talk about classification and regression in short, and then we will just move to coding in Jupyter Notebook. So that basically these weekly webinars, the objective of weekly webinars is to have kind of tutorials for the lessons. So yeah, then there is classification. First we'll talk about the logistic regression. In the courses you may have covered the SVM also. We will also try doing that. Then there is KNN, which is I think not covered. I'll talk about KNN in brief. So KNN is the simplest kind of classifier. Here the So I should just go to the classification slides. So in KNN, whenever a new data entry comes, you see the corresponding K neighbors to it. And based on a voting of majority, you decide which class it should go. So I think we can just Google some images. KNN. Okay, so as you can see here, yeah, you can see here the new example sees the nearest neighbor to it, because the value of K is 1 and the nearest neighbor to is it is a star, so it automatically gets the value of star. So in the case of k, value of k, say say 3 or 5, it will do a majority voting. So yeah, for example, here the k value is 3, and there are two green classes in the circle and one star class. So the new data entry automatically gets assigned the green class. um, Coming back to our um, so classification we have done. So we will talk about logistic regression here. Uh, in logistic regression, you kind of estimate a probability of a particular data entry having to a particular class. Let's say the probability of a person having a disease is zero point 0.8, considering the gene sequence of his medical data. Then you can say that it's if its probability is more than zero point 0.8, he will be assigned the class of 1, that is having disease. Logistic regression works on the same principle. It finds a value between 0 and 1, and then assigns a class depending on the value and the threshold. So if you see the formula, it uses a sigmoid function whose value ranges from 0 to 1. So here the independent variable is t. So you can see if t goes to negative of infinity, the minus t goes to infinity. So 1 upon infinity would be 0. So you can say as the graph is going to negative, it is reaching the value of 0. Correspondingly, if the value tends to infinity, the value of t tends to infinity, then it becomes 1 upon 1 plus 0, that is 1. So it reaches the corresponding value of 1. So it works on this simple mathematical formula and then finds the associated classes. Okay, so you can see that this is binary classification. So we have binary classification or multi-class classification. Here, you are dividing the data entry into two parts, like email, whether it is a spam or not spam, a tumor, whether it is malignant or benign, a transaction, whether it was fraud or it was genuine one. So these kind of things happen. As you will see in the upcoming lectures, you will also learn more about true positives, true negatives, false positives, and false negatives. So basically, the scenario is if you predict something as true, and if it comes out to be true, then you say it is true positive. If you predict something as true, if you predict something as positive and it comes out as negative, then you can say false positive. Your prediction was false and the entry was positive. Entry was not positive, so it was negative. So these kind of things, we will talk more about this when doing the metrics of the different models. SVM. So we'll also talk about SVM. In SVM, we basically find a hyperplane to divide our dataset entries into corresponding parts. So this problem talks about binary classification. Here we have a hyperplane which divides these two entries into these dataset entries into two regions. Then whenever we have to assign a class, say we want to find the class of this ball, the topmost ball, then we say that it lies on the right side of this line, so it is of class red. And if a ball is on left side, it is on class blue. And this line is found by using these two red ball and blue ball, which are closest to each other. We basically find the perpendicular bisector of these closest point, and it becomes our classifier or separator or hyperplane. So talking about regression, as I already told you guys, that regression basically finds um, finds out a value. So it may be float, it may be integer. It is predicting some mathematical value. Um, it is basically finding a number for it. It can be your movie ratings. It can be your let's say the amount of rain that can happen on the weather forecast. It can be um, it can be anything. It can be like the prices of houses based on the corresponding scenario, like size of the house, the region of the house, number of windows, number of doors. So you see, this is also the graph that I have just copied. This blue line is a linear regressor, and these are the different data points, the black ones. And this is the distance that every corresponding point has with the regression line. We actually estimate the distance using different metrics, like for example, root mean square, mean square, and all those kind of things, where we take the difference between the predicted value and the actual value. uh, okay, so I guess I covered it up pretty quickly. So I'll just now. Okay, I am still visible, right? Yeah. So we should. Okay, so there are some comments. I'm sorry. I say like, am I the only? Okay, so it is working fine with Ahmed. Uh, so let's do some coding. I guess you all have installed Jupyter Notebook. So this is how I do it. You may have different systems, different operating systems, and you may do it differently. On Linux, I do it like this. I just type Jupyter Notebook. Yeah, so this is my directory. I have already downloaded the data sets like iris and other. These are pngs, and this is some old files. So whenever you want to create some new file, you go to new. These are all different kernels. So I use Python 2, 3, and this is for torch. We will be covering it later. And this is my some local environment. So I'll go with Python 3 then. Okay, so let's name it something. Regression. Okay, so this is how I save it, and this is how I add a cell below. This is how I cut it. This one is for copying. This one is for pasting. This shifts the cells up and down. So in Jupyter Notebook, you have the option of compiling one block at a time. So whenever you want to compile something above other segments, you can just shift them up. And this is for down, this is run, and this stops the kernel. And this is basically where you mention whatever you are typing, whether it is coding or markdown, heading or convert. So first I'll go with markdown. I'll just markdown tells you markdown, you basically put the titles. So it depends and the size you can control by the number of hashes. So one hash is a big size, then second becomes smaller, then third is more smaller, and the fourth is smallest, and then like that. After a range, after let's say 6 hashes, it stops converting, reducing the size. So we will go with 2 hashes. Let's say classification. Uh, okay. So today I thought that I'll be doing one on iris dataset. So I had opened some. Okay, so this is the UCI machine learning repository. You will be using this a lot. It has multiple classification and regression data sets. So for practice, it is quite recommended. So here you have this data folder and dataset description. You can click and download it. I have already downloaded it, so I'll just read it using the pandas data frame. I'll talk about it later. So these are the 5 columns that this data entry has. So first is my sepal length. Sepal is basically the bottom part of the flower, and the length and width. Petal is the typical flower that you see, the colored one. So based on these 4 attributes, I have 3 classes, whether the plant is of Iris setosa, Iris versicolor, or Iris virginica. You can download it and save it. I already have it in my folder. Okay, so I have Iris data. So I'll just Oh, to Jupyter Notebook. So first, let's import some libraries which we will be using. So it's conventionally pandas is imported as PD because pandas is a we try to give the libraries some acronyms so it is easy to use later. We do not have to type much basically, and also we may be using NumPy. Okay, so actually, I do not remember much of the syntax, so I frequently consult the documentation of the sklearn. You should also make this a habit of using sklearn quite a lot. Okay, so now I'll be using pandas. Pandas. So basically, there are three parts of the this whole process. First is taking out the data and basically filtering out the data in the better way, or you can say data analysis. Then you say you do the feature analysis part where you find the corresponding important feature vectors which are important to find the appropriate classes. And then there is model building. So for data filtering or extraction part, the pandas is quite good. So it divides the data points into data frames. So I'll just name it as DF. I'll, if I remember it correctly, PD CSV. This is how I read it. And iris. So let's see. Okay. So if it is working well, then it means that I have imported the file correctly. For example, it can show error. Let's say I delete this part. Now this is telling me there is error in this line, but I was doing it correctly. So now I have imported the data frame of iris. Now let's see how does iris look. So you can see that there are indexes on the left side and there are classes. There are total 149 rows. It is telling it should be 150. I guess that's the problem. It has made the first row as the columns of the data frame. I think we should correct it. So we will just put it down dot location -1. So this is how I access a particular row. So I want this row to go at -1 so that I can use it later, and then I can change the columns. Okay. So first I should just type the columns. Df.columns. Let me see how many columns it has. So yeah, it has, you can see that it has 4 columns. But it is taking the first row as the column 5.1, 3.5, 1.4, which should not be the case. But first convert these
And then,
values in the float value. Hello. Yeah.
excuse me, do we want to use a particular column name now? Or is it enough just to type into the pandas read CSV that we have no headers?
Sorry, I didn't get your question. You are asking me why are we are using columns?
No, what is our purpose now by
Okay. Yeah.
transforming
Yeah.
these
Yeah. Yeah. Okay. Okay. So if you see,
so-called headers?
yeah, if you see that we have imported the data frame correctly, it shows no error. So when we print the data frame, we see that a particular data row entry, that is the first row entry, has been converted as the column names. So actually it is a data entry. It should not be just the title of the columns, right?
Yeah, sure.
Okay, so what we want is we want to make put all those rows down. That is, this should go at 0th place, and then we can just give new names to our columns. Okay, so new names, I think
Nice.
we'll be giving the names from this status. Okay, so names are sepal length, sepal width. So these 4 names we will be giving to our new columns. Okay. uh, I hope it's clear. Okay. So first, what actually happened is when this first row is converted into the headings of the column, then the second row will be converted into the
Hey, can you hear Viranda now? I can't.
Me neither.
Nah, I can't
Kind of.
either. I think he's gone away.
Okay, thanks.
Okay. Yeah, he will be back. Just wait.
Hello, hello.
Hello, you're here.
Hi.
Hey. Yeah.
I got disconnected in between. Till where did we cover? Did we cover this till this part, incrementing the index?
Excuse me? Could you repeat it, please? It was
Uh,
distorted.
so actually, my call got disconnected in between till where we covered the code. Did we reach this part, incrementing the index?
We cannot see your screen yet.
Okay. Wait. Okay, entire screen. So now you can see it.
Yes.
Okay. So I'll just basically we covered the so all of you know till this part we covered, like we convert all the values of column headings into the float values because they were using the first row as the column titles. Then we assigned these column values to the -1 value because we wanted to use this first row, and then we incremented every index because indexing should start from 0. And now when we print it, okay, so at any point of time if I'm not audible, please let me know or message on Slack. So yeah, so on now 0th row goes to the lowest point. You can see that the first row data has been preserved here. All the values are converted to float, and this part is left as it is as string, the class. So now we will just sort it so that the first entry goes on top. Okay, so I guess this was the sorting. Okay, yeah, it worked. So if we see it, yeah, as now you can see that we have copied the first row here because first row by when we read the data from this iris.data using pandas, it automatically converted the first row as the title columns. So we basically copied this row, converted it back to float and made it here. Now we should have 150 rows because that's the size of iris. uh, Now we can just change the column names of tf. So if you see the column names, it was sepal length, sepal width, petal width. So we will convert it back. Sepal length. Basically, I'm assigning a new value, new names to the columns of the data frame. Sepal length. Okay, so the last column should be our class. So now it should work. So yeah, so now we have a so you see that these are all the things you need to do with data pre-processing of the data. You do not get always the data in your desired form. You have to make it like that. So suppose if in my data there was some missing entries, then I had to do something about it, like filling it with zeros or filling it with a mean of the values in the columns or something like this. This is called pre-processing of data, and it is needed in real life data. So here in data frame, what actually happened is my first row got converted into the column names. I had to copy it back to the first row and then assign new names to the columns. Okay, so we will just keep the printdf as it is, and now we'll just no. Okay, now I think we should split our data into the training and testing things. So I guess for this we use train test split. I'll just check out the syntax. Yeah. Okay. So you see, in train test split, this is the syntax. Here they are using first entry as x, then y, then test size, and then random states. Okay, so first I should define my x and y's, but first I should import this thing, train test split. So let me just copy it from here. This was my Jupyter notebook, and now I have imported the train test split. Now I need to divide my data into two parts. One should be my features or my attributes, other should be my target. So let me save my target in say y. So data in pandas, you just you access it like this, like a dictionary. You just put df class, and then by this column, iris setosa, iris virginica, all this will go into y. And I also need to make an x, which should have all the other columns. So I can just drop my column class from it. So what drop does is drops this find last column from it, and all the other things are stored in x. So yeah, so I have my x and y now. So let's print x and y to see how they look. Okay, so you see that x has all the data entries except the class, and if I do the same with y, it has all the data entries in the classes. Now this thing can also worry you because the all the classes are in particular order. So if we divide, just let's say just we keep the last 20 entries at last 20% of our entries as test set, then it will contain only a single class. We should also permute the whole values. For this we use the train test split with a random state. So first, let's go back to the sklearn. So you should keep it habit to frequently go to sklearn, because you need to read these documentations to understand this. Okay, so they are doing this in this manner. So output is xtrain, xtest. Xtrain is basically the features of our training data. Xtest is features of testing data. Ytrain is the target variable from training data, and ytest is the target data from the test data. Uh, so it is keeping a random state here. So for random state, I should tell you that basically default it is none. So if there, yeah, so default it is none. So if the random state is none, then you can see different results for each time you fit and run your model. For that, we keep a fixed seed for our random state. That here, in case you can keep 4201, it doesn't matter. 42 is a popular number because it is uh, I don't know if you know that it is the answer of life, universe, and everything. That's why it is such a popular number to the 42. But we can keep any number here. What it ensures is every time your model is run, same entries go into training and testing split, and same accuracy you get. So while submitting, if you use this random state, whatever accuracy you have got in your Jupyter notebook, the evaluator will get the same value. So we will just do the same. Test. Okay, so it was like this in test split. Yeah. So now we had x and small y, and then we have the test size, I guess. Yeah, the test size. Test size, we will, in this experiment, we'll keep 20%. Let's say 0.2. And then random state, we can keep 42. You can keep any number here, 0, 1, or any number. Yeah, this one also worked without any error. So if we see, let's say we see what values we have got in Xtrain. So you see it has 120 rows, and these entries are shuffled. If you are not sure, you can also see the Ytrain values. It should be like this. Okay. You see that not all the entries are from the same class. They have been shuffled, and now we have all the sorts of classes in our test and training data. Yeah. So test data is this one. This is versicolor, versinica, and setosa. So yeah, data is fine now. So I think we are done with our training and testing split part. Now we can just import our first model. So we covered today logistic regression. So I think we should just go with it. So logistic regression, sklearn. Okay. Let's see how do we import it. Okay, so we import it like this. Okay. So now we import it. Yeah, so it worked pretty well. Now that we have imported it, we want to make our own classifier. So let's say linear regression classifier. It takes logistic regression that we just imported. And we can give it some values. Let's see the parameters that we need to go. So yeah, so it has some values of solver. So solver can be different sort of. It can have atom, it can have gradient descent. These are the ways how we reduce our error and try to reach the accurate value. So if we see the solver here, yeah, so these are the kind of solvers we have with uh, logistic regression. So just let's go with the example. So it has LBFGS, so we will just do this one. So random state, as I said, you can keep any number apart from none, so it will be okay. So here they have used 0, so I'm doing the same to avoid any confusion. So solver, they have done LBFGS, LBFGS. So I'll do the same. So to understand these parameters more, I would recommend that you go through the documentation, explore more on them, and try to learn more about it. Uh, Now that we have classifier, let's just fit our classifier. So basically what fitting means, fitting is basically training. Okay. So fitting is equal to training. So you are basically giving it a feature value, feature attributes, then target attributes, and then you are telling the model to learn from those feature and understand what kind of target values should it possess. So we have X train and Y train with us. We will use these two to train our model. So LG CLF. Okay, let's fit it now. So we had X train, I guess, and then we had Y train. What we are telling is the model is you should use the data from X train and understand the classes from Y train. So let's see. So yeah, fitting is done. So it is telling us it has some few parameters that we set, and then there are others that were already there. They were the default parameters, so you can read more about them. So now that we have fitted it, we need to see the prediction of it. uh, okay, so basically how we do prediction is LGCLF dot predict. And so now we have trained our model on training data. Now we will test it on test data. So X test. Yeah, so it is giving me these values. So these are all the different predictions it has done. But we also need to know how accurate it was. So we need to import the accuracy score from sklearn. So let's Google that also. Sklearn. Okay. So basically accuracy score is works like you give it the true values and prediction values. It tells you how many of them match, like the percentage of how many of them match. So first just import it. Okay, so let's import it here only. Yeah. So now we can just see our accuracy. You see, I have kept this value as one of the parameter of accuracy because accuracy takes predictions and the true values. True values I'll give it as y test. So y should be small. So accuracy is not defined. So yeah, so we have imported it, but we need to also take it as accuracy score because that's the value. Okay, now let's see. Okay, so now it is giving me 0.96 accuracy. That means 96% of values match with the predictions and the true values. So I think we have done linear logistic regression. Now, when we are doing classification, we should also cover SVM because we also talked about it. So let's see SVM, sklearn. So you see, for each and every model, I have a corresponding documentation in sklearn. I do not need to memorize these syntax, but I do need to understand the concepts behind them so that I know when I need to use something. So let's just import it. Okay. Now okay, so let's just press shift and enter to compile, and now make our own classifier. So this works like this: svm dot svc. Okay, so now our svm classifier is an instance of the svm function that we imported, right? So it's like this is kind of object of this function, of this class of svm. So now let's, without wasting any time, we can just fit our classification model. So for fitting, we do use xtrain and ytrain. Yeah, so we use the svm classifier that we imported, and we passed it the xtrain and ytrain. So it is giving me some parameters that it has. So these are, you can see that these are the by default parameters because we did not pass any in it. So it's okay. We can now see the predictions also. But for predictions, we will still use accuracy score. Okay, so accuracy score. CLF dot predict and compare it with y test. Y should be small. Test. Now it is giving me 100% accuracy. So I think we should make sure that this accuracy is correct. So I think we should do some grid search on it. Okay, so in the first assignment of the Titanic dataset, you might also have done the grid search thing. Titanic dataset is also small. It has approx, I guess, 880 or 887 something rows. So that dataset is also small, and this 150 rows dataset is also small. But cross validation won't have much effect on it. But we should always try to see the grid search cross validation to see which are the optimal parameters for our model. So we can do some grid search CV, because right now we did not pass any parameters. We just took what were default. Okay, so let's see how does it work. So these are different parameters. These are the parameters that we pass on, and then we check the performance for each parameter. Then it gives us the optimal score from each one. So let's first import it, and then we can talk about different parameters. Okay, yeah, it worked well. Now let's make some parameters. Let's see the different parameters in it. So there is C and there is kernel, and with kernel associated is a gamma. So here gamma is scale. So let's see the value of different gammas. Here we have, okay, so it is giving it some gammas like 0.1, 0.2. Okay, so we'll just make a grid for our parameters C and gamma. So let me say my params grid. Okay, so I can make it like this. First C, I can just use this, and then let's just go with the values like 1 or 10 or 100, or we can go back like 0.1, 0.01, like this. And also I had gamma with me, so gamma should work like this. So value of gamma I can also do in same way, 1, 10, 0.1, 0.01. Gamma should not be too large. It will just keep on going for a long time then. 0001. Okay, I have defined my parameters grid. Now let's see how it works. Okay, so it goes as this grid search CV. We pass our parameters, the value of CV and SVC. Okay, so my grid should be like grid search. Grid search, was it grid search CV? Grid search CV, yeah. Okay, now I can use a different object for this from SVM. And what was my parameters? I can just use. Basically, this idea I got from an assignment I did a long time ago. So this was the kind of thing I did. Used C and gamma in the multiples of 10. So this is quite common to use. You can check out, and then you can see that many blocks are there which use such kind of values. So it is pretty conventional. And there's, okay, let's see the other, if there are any other parameters. Okay, so there is verbose. Verbose tells gives us the logs of the function. So I think it should be, it should not be false here. We will just set it to some non-zero values, and then it also had a refit value. Okay, so refit value is also there. Okay, refitting the best model on the data set. This is present if refit is not false. So we will just put the refit as true and see what are the different findings we get. Let's verbose. So fit to. Okay, now it's time to now my grid is ready. Grid search CV is ready. Now it's time to fit the training data in it, and it will tell me different accuracies or parameters corresponding to different values. So there will be list of a permutation of these parameters and then corresponding accuracies. So let me fit it. Okay. So it is the same that we have been doing till now. X train, Y train. Yeah. So this one I have also done earlier, like fitting three folds. So you can see that's these are the different values of C and gammas here. First one, and then all the values of gamma, then the value of C change, then all the value of gammas, and the score is with them 95%, 97%, 92%. So now my grid knows which is the best set of parameters to give me the output. So it is giving me the parameters here. Now it's time to test it. So we'll just let's just copy it from here. Okay. So guys, at any time if I get disconnected, please post on Slack or something, like, because I can on my phone I can see the Slack, so it might happen that I get disconnected in between this call. Okay, so now just let's see my grid. So you might be observing that this is the same set of operations. This is the similar kind of work that you have been doing till now in your assignments, uh, to create different models. So that's the same for this whole lesson. This is the kind of thing we do. Then in the project work, there is the comparison of each and every model and their accuracies, and also there you would have to make different graphs and show that why this model is the best model out of all those, what kind of data feature selection you did, what kind of data pre-processing you did. All these things will be needed uh, to write in your assignment. Okay, now just let me see the accuracy. Okay, so yeah, it is again coming out to be one. So I guess both of these, this SVM is working quite nicely in this iris data set. Basically it is possible to divide the whole data set into three categories. So for multi-class SVM, what how it works is it works on the principle of one versus all. So if I have three classes, 1 to 3, it will take my 1 as class 1 and 2 and 3 clubbed together as class 2, and it will do the same for class 2 and 3, and then it will find the best uh, what to say, the best hyperplane to divide it. So I guess we have spent quite enough time in regression. I guess on classification we always spent our whole time. So there is only 7 or 10 minutes left. So we will just rush for this regression thing. Okay. So here I go to Markdown. I do regression. Okay. Yeah. So for regression, I think we should do first linear regression. It is the most basic one. Yeah, regression. Okay. So first let me import it. Okay. Yeah. This works quite fine. Okay. For also, I at this point of time I should tell you that for linear regression we cannot use accuracy, because now we are doing regression. We have to check out for the error between the accurate value and the predicted value. So we can use different metrics like mean square error. So mean square error we can also import. Let me see how it's imported. Square error sklearn. Okay, yeah, it's just simple mean square error, and it takes two parameters like the accuracy score, the predicted value and true values, and based on these two lists it tells the corresponding mean of square errors. So basically for corresponding values it divides them, takes their square, sums them up, and then divide it by the number of entries. So it finds the average of the squared errors. Okay, so yeah, so I should, I think, copy this from here. Mean square error. Now for regression, there are also different data sets that I search before coming to this class. UCI. Yeah. Then there is diabetes data set. So I guess sklearn also has a copy of. We do not have time to copy and then do all the feature processing with it. sklearn diabetes data set. sklearn has these, yeah, load diabetes function. So sklearn can also help you load the data set directly from sklearn. You do not need to every time go there, download it, and do all the feature processing. sklearn has done it all for you. So yeah, only sklearn.dataset.load diabetes. So let me say my diabetes data set. Okay, so for data sets, I should check what it was. sklearn.datasets. Okay, so I should import data sets also. sklearn.linear model. Okay, let me import from sklearn data sets. Okay, now I can call out for my diabetes data set. I don't know how am I doing, but if in any way this tutorial can help you out in doing your assignments or projects, that will be a major achievement for me. Okay, so just let me know if you have any doubt in this whole tutorial, or if you want to ask something particularly technical. Okay, diabetes datasets, then you see that I am not using any knowledge that I have previously. I am going to the documentation, reading about it, and taking basically seeing the syntax from there. Okay, so sklearn.load diabetes. Yes, I saw from here sklearn.diabetes datasets. sklearn.datasets I imported here. From sklearn I imported datasets. From datasets I did load diabetes like this one. So I think it should work. Yeah, it is working. Now let us print this one. Okay, yeah. So this time it is not in pandas because we did not use pandas to use it. It is in the form of arrays. Okay, so these are different column names, different target values, uh, and the feature values with it. So now diabetes is divided into two parts. There are diabetes.data and diabetes target. So they have divided it into two parts: data. So this is a whole series, and then from this series we can do extract out data and target. So it's like dictionary. So if you use the key data, you get all this, and if you use the key target, you get all this. Okay, so my x should be like always my features. So I'll use the diabetes or data. Y I'll use diabetes. Okay. Uh, So this should work. No, diabetes is not defined. Diabetes data set is defined. Okay. So I have given it a name. I should stick to it. Okay. Am I still on call? Yeah, I'm still on call, right? So now we'll do the same thing. The splitting part. Splitting we can just yeah, copy from here. XY, same thing that we did earlier. We did not do anything different. We are using these XY, and these four are our outputs. Yeah. Now I have X training, X testing, Y training, and Y testing. Now it's time to apply linear regression. Let's see the syntax again. Okay, mean square error I have done. Accuracy I have done. Uh, this is logistic regression I have done. Yeah, linear regression. So now it is using linear regression dot fit. So we'll be doing this in our own way. That how we do it. We'll define our own linear regressor. Regressor. Okay, so we did imported linear regression here. We just copy it here. Linear regression. Okay, let's see if it works. Yeah, it worked. So now we need to just fit it like we always do. So we give it the training data and the training targets. So it did all the fitting and stuff. Now we need to use this mean squared error thing because we want to compute the error between them. So let's see, mean square error. It has two values, y predictions and y test. So y test would be the same. In case of y predictions, we can write linear regressor dot predict. Okay, linear regression. I think we have run out of our time, so I'll just rush. Okay, x test should be there. X test, x is capital, and then mean squared. Okay, so spelling is not right. Okay, so you can see the mean square error is quite high. But then there are other regressors also we can use. So one is neural network regressor. You will read about uh, neural networks in the later sections. Okay, so yeah, there is MLP regressor. It is quite common. So multi-layer perceptor and regressor, it's is full name. So in multi-layer, there are some input layers, and then there are in between there are some hidden layers which have some activation functions. Here they are using the ReLU and the solver Atom. We'll just use the default arguments. We won't change anything. And then let's see if this can help. I should not have covered it just now because you might not have reached till deep neural network stuff. But I think we can just see whether it has how better the neural network stuff is than as compared to linear regression in a simple data set like diabetes. Okay, so I think there is. So it should work just like that only. We should import it somehow. Okay, there is sklearn.neural network. Yeah. Okay, so this one, skneural network.mlp regressor. We'll just copy it. Okay, so but first we should do the sum from stuff from skneural. Okay, so we want to import this, so we will just write from sklearn.neural network. We should import mlp regressor. Okay, now I think it should work. Yeah, it's working. Now we should make an instance of this. Let's see, my mlp regressor works like mlp regressor, and then I need to see some parameters. Okay, so by default hidden layer size is 100, and then there are activation ReLU. So let's see, instead of 100 let's pass 500 and see how good it is. And solver we will keep the same. Atom, it is by default Atom. We do not need even to type it here. Okay, now comes the training part. So I just do my MLP regressor dot fit x train y train. Yeah, let's see. Okay, so it has some error. Okay, yeah, I should not put 0 here because it is the size of the 500 is the size of the layers, and 0 is and the second is the dimension of the input entry that can go. If I do not mention any entry, that means data can be of any dimension. So I'll just, yeah, it is now trained. Its alpha value is there, its batch size is there. Don't worry, we'll also do a webinar on neural networks later weeks. First our target is to complete this thing. Okay, let me see where it was. Okay, so first our target is to complete this supervised learning part with this project. So till next week, many of you will be would have completed this support vector machines and would be in the ensemble methods and model evaluation metrics. Some of you have already reached here. So next week we'll also do something on evaluation metrics maybe. And when we, this is the way how we compare the differences of models, their accuracy, and all those accuracy, precision, recall, and the theoretical stuff is also there. Then this is our project, this is our deadline. So your deadline is based on when you join the course. For me it is showing due in 21 days, for you it might be different. Okay, yeah, we were doing something. Okay, yeah, so we trained the model. I think it is the last thing we are doing for this session. We have already we already did all the things that I supposed. This thing I'm doing extra, I don't know, because maybe this way we can see whether neural network perform any better than linear regression or not. So this is not MLP regressor here, this is my MLP regressor. Okay, so this is my MLP regressor. Should predict something. For prediction it should have the X test, then it should be compared with my Y test. So error should be as accuracy should be as high as possible, and error should be as low as possible. Let's see. Okay, so maybe something I did wrong. Okay, yeah, on Slack there is a message. Okay, no, it's not you guys. Okay. I maybe 500 is too much for it. I think if the number of layers get too much, then it also leads to errors. We need to find accurate value for it. Now we are going with default values. Let's see how much it. Okay, here also it is showing this. I'll have to check, because normally it works better than a linear regressor, but I guess this data particularly, this is giving this error. So this I'll check. I'll just try some different values and understand why this is. So you can also check it out. Normally it performs better than this one. So if diabetes is the data set. Okay. So yeah, so it also may mean that this data set is close to a linear regression line. Maybe it was easier to fit it into a linear model than using a deep neural network for it. Basically, deep neural network, what it does is it extracts those features on its own. It tries to understand on its own what are the different sorts of feature. For example, if you have any image data set, it will tell what is the length, what is the breadth, and other things in it. Okay, so I think it's quite late here. So I'll stop sharing. Okay, so anything you might need to ask? You want to ask something? I think was this session helpful, first of all?
Yep, sure.
Yeah.
Thank you.
Yeah.
Yeah. Okay.
It's a good overview, you know.
Sorry.
It's a good perspective on all the different methods we will be using.
Yeah. So my objective was today we're here was to show you what kind of project work you will be doing. So in project work also you will be doing this all sorts of models, and you will be comparing them on basis of their accuracy. Like first I did logistic regression, and then I compared its accuracy with SVM. Similar way I did linear regression, and then I compared it with MLP. So yeah, these are the kinds of thing you will be doing. You should look out for pandas and NumPy. As you noticed that I did not use any like I was pretty bad at syntax. I used to copy it from here sklearn all the time. So it's okay. Basically, this is how every data scientist works. They do not they frequently visit this website because it's quite good and explains everything in detail. So I think it's all for today. So we can stop it right now. Like, it's if it's okay from all of you guys, we should end it here, right?
Yep. Thank you.
Thank you.
Okay. Yeah.
Thanks.
Thank you.
Thank you. Bye bye.
Bye.
Okay. Bye.